On this problem, we need to first figure out the absolute extrema for the given function, and we do have an interval. Whenever you have to find extrema, whether it's absolute or relative, you do need to find critical numbers. So your critical numbers come in three varieties: the kind where the derivative is 0, the kind where the derivative is undefined, and the endpoints. Any x values that make any of those three things happen will give you a potential location for a min or a max. For our case, let's just jump into what y prime is. We can use power rule for each term. We get 3x squared minus 1x minus 2 and then plus 0. The last term is a constant in the original function. Now, there is a potential for the derivative here to equal 0. There's not going to be a potential for the derivative to be undefined because it's a polynomial function, so I'm not going to worry about that. And there are endpoints. The endpoints are what they give us for the x values of the interval. So let's focus on where this derivative equals 0. We can perhaps factor this. We get x would be negative 2/3 or x would be positive 1 for our critical numbers, as well as the endpoints negative 1 and positive 2. So we have 4 critical numbers to test out here. Let's plug each of these critical numbers back into the original function to get their y values. That's how you find absolute extrema. You just find all your critical numbers, see which one gives you the greatest result when you plug it in, the original function. That's your absolute max. See what gives you the least result when you plug it into the original function, and that's what gives you the absolute min. Okay, plugging in negative 1 gives us 1.5 as a result. Plugging in negative 2/3 gives us a little more than 1.5. Plugging in 1 gives us negative half, and plugging in 2 gives us 3. Of these 4 results for y values, 3 is the greatest. So the ordered pair 2, 3 would be our absolute max. Of these 4 ordered pairs, negative half is the least. So the ordered pair 1, negative half would be our absolute min.